my name is Lectra, and this is the last of my Math for Teachers videos. This lesson was actually supposed to be in an actual classroom with real students, but whenever COVID pandemic happened and the state went under a shelter-in-place rule, and then schools got canceled till the rest of the year, this became another one of those weird videos where I'm talking to imaginary middle schoolers in my living room. In this lesson, I will be discussing geometric nets and how we use them to solve for total surface area. Let's start with what is a net. So a net is a three-dimensional shape that's been flattened out and turned into a two-dimensional shape. So we could think of it as like a box. When you flatten all the pieces out, this is the box, and then if you fold it back up, you get a normal size folded box. A few tips for using the net, whether it be turning a net from a solid or turning a solid into a net, we have to keep in mind that they both have to have the same number of faces and that the faces are the same shape. So for our cube, the faces are squares, and we know that there are 1, 2, 3, 4, 5, 6 faces on the cube. So when we do our net, we have to make sure that there are 6 faces on the net as well. Cube faces are squares, so all of the faces on our squares, or all of our faces on the net have to be squares. Not only can we use this for our faces, we can also use it to identify our edges. So if you fold up our net and turn it back into that three-dimensional shape, it's super easy to just count out how many edges you have and how many vertices you have. So here are just a few nets with their properties. Not only do we use nets for identifying shapes' properties, but we can also use them for surface area. Surface area is simply the sum of the areas of the faces on the shapes. So it would be the sum of all of the triangles on this triangular base pyramid here, or the sum of all of the squares on the cube. Another way to think of this is if you're wrapping a present, the surface area would be all the paper needed to wrap the present. So the surface area would be all the pieces of paper needed to wrap up the total box. So as you can see, when you're showing the net of the shape, you can identify all of the shapes needed to find the area in order to actually get that full surface area of the cube. Same thing for any of the other shapes. So if we had a pyramid shaped present and we opened up that net, we can identify the shapes as 4 triangles, find the area of all 4 triangles, add it all up, and that's the amount of paper we need to wrap that triangle shape, or that pyramid shaped present. It might be a little more confusing whenever we do have to wrap those cylinder type presents. So looking at the net can actually help. The net for a cylinder present would be the 2 circles for the ends and a rectangle. So solving for the area of the circles and the rectangle can help you identify how much paper you need to completely wrap that cylindrical gift. So if we had a triangular prism type present, we would open that bad boy up for the net, and you would see that there's 3 rectangles and 2 triangles. So you'd find the area of the 2 triangles and all 3 rectangles that should generally be about the same size, and you'd add them all up and you'd have enough paper for your rectangular prism. So here is a example of finding surface area of this little rectangular prism present here. If we draw out our net, we can see that there are 2 rectangles with the dimensions of 3 and 6. So this is 3 by 6 here, and this right here, the base, if you sat it on the side, would be a 3 by 6 as well. the two rectangles with dimensions of 2 and 6. So the same here. All of these lines are going to be parallel, so they're all the same. They're all congruent lines. And these are both congruent lines, so they're also going to be the two cylinders because that's the edges that meet. So this right here and this right here are the 2x6 rectangles, and then we see two more rectangles with a 2x3. Those are our ends here, or in the picture, the base and the top. So in order to find the total surface area, you would find the area of all of the rectangles, and then you'd add them all up, and your total amount of paper you need to wrap this present would be 72 centimeters squared. Surface area is on your star reference sheets right here, but sometimes those formulas can be confusing, and right now we're just introducing it, so we're not even gonna go into it yet. We're just now learning how they work. Those formulas can be confusing, so sometimes when you get confused, you're gonna have to think back on this little method when we draw out our net. It's a little extra work on the math, but it'll make it easier by using these simple area formulas that we all know how to use to come up with surface area. So after going through this intro to surface area and how to use nets lesson, I would probably provide some kind of questions that ask them to identify the shape or identify the net or draw out the net and then solve for the surface area based off of the given numbers, dimensions of the shapes. This would allow them to practice making nets, solving for the surface area, and naming shapes in general. These nets are an awesome way for students to be able to physically see the shapes form into those 3D shapes from these 2D squares, or see this pyramid form from a bunch of triangles into the pyramid itself. The cylinder, it's kind of weird, but it helps them understand how to measure out the shapes, because the cylinders are a weird shape whenever it's flat into 2Ds, but folding it up we can see that it's just like our can of soup. This would be a cool accommodation for those sped kids, is probably providing some little manipulative nets. It'll allow them to work through it, physically see them form, and if they need to, they can either rip off or cover up what they've already solved, so they know how much more they still have to solve in order to get the total surface area, and then add it all up so they can wrap up their presents. These manipulative type of nets are awesome because that not only are they for actually understanding the net, but they're a great way for those students to be able to break down into those 2D shapes and find area, because sometimes those really long formulas can be confusing, and finding area of triangles and rectangles is a little easier to do. This concludes all of my Math for Teachers videos. Thank you for watching. Stay safe and stay home.